Hi there, today we're looking at this. This is the Bluetti EB70 power station. Now, I'm going to cover the specs of this before I go into what I like and what I don't like about it. But just to say at the start that this was sent to me for review, as per my normal terms with any of my clients. They have no input into the video. They don't sort of they got no editorial control. These are my opinions, but yeah, just to put it out there, this was sent to me. So, yes, what is this? Well, it's a power station. It is one of the many that are out there, but I think it's fair to say that the big players in the market really seem to be EcoFlow, Jackery, Anchor, Bluetti. They're the sort of main ones that come to mind when you think about these sort of things. So what we have here is a 716 watt-hour lithium iron phosphate battery. And we have a DC section here on the front, and we have an AC section. You've got your display here, and you've got your inputs. There are no inputs or outputs on the back of the unit at all. On the DC side, we have two power delivery 100 watt outputs. We've got two USB-A 5 volt 3 amp outputs. We've got two 5521 10 amp outputs, which is nice to see. A lot of the time these are limited to 3 amps, but these are 10 amps. And I must point out that is 10 amps in total. I will be testing that in a second to see whether these ports can successfully output 10 amps and what happens to the voltage and stuff like that. And then we've got a 10 amp cigarette lighter socket as well. So they've actually named it as a cigarette lighter socket, which is strange because you tend to just see it as a 12 volt sort of DC car socket or something now, but it's actually been named as a cigarette lighter socket here. Then we've got the AC inverter side as well. And the AC inverter is a 1 kilowatt inverter. It's a 1000 watt inverter with a 1400 watt surge figure on, in my case, two 230 volt UK sockets. The sockets, I don't know if you can see there, the green, they have the earth shutters and the shutters across the live and neutral, which is good to see the sort of full safety covering in there. I did a review of an All Powers S2000, and they reuse the sockets on for multiple regions, and so they just find a way to fudge them so they work across all regions, and therefore they have to miss out the shutters that are part of the British standard. So good to have it in there because it's one of the best standards in the world. And yeah, you see the safety side there is covered. And then you've got this light on the front as well, which is an LED light that has a low, bright, and then an SOS function. And then the display here, which gives us our input and output, displays whether we're using the inverter in 50 Hertz mode or 60 Hertz mode. Tells us whether we've got eco mode turned on. Eco mode is something you probably want to leave on. It just turns the unit off after 4 hours, if the inverter off after 4 hours if it hasn't done anything to save excess parasitic type drain or that sort of just continuous drain that an inverter will cause on a unit if it's left on. And then we've just got the battery status. Now, the battery status is listed in 5 bars, and I'll come back onto that in a second because that is something quite a few people talk about, but I'll give you my opinion on that in a second. And each of the AC section and the DC section are powered individually by these just these touch buttons here, and the light is powered separately. And then our input here is 12 to 28 volts, maximum of 200 watts for the MPPT controller on the solar, or maximum of 200 watts, so 8 amps on the DC side as well. And I'll also cover in a second how long it takes to charge this from flat, because I've seen varying figures on their website. One part of their website says 3 to 4 hours, another one says 4.5 hours or something like that. So I'll test how long it actually takes to charge and how much power it takes to charge this unit. So I figured the best way to test the 1 kilowatt inverter, so although it's only a 700 watt hour unit, it can output 1000 watts at hopefully 220, 230, 240 volts here on the mains. I thought the best way to do it would be with a toaster. So there's 3 things we've got to watch out for here. 1, can it actually do it? 2, can it retain the voltage? So if we turn the mains inverter on now and take a look at this, we should get a voltage reading on there, which we do. So we've currently got 230 volts, pretty steady, 229.3 volts. Can it retain maintain 230 volts at its full kilowatt rating. And the third thing is, of course, how much noise does the device make when it's actually doing this? And let's see what it does. Oh. No, it would seem. That's tripped. Okay, so I've temporarily plugged this into the wall. This is actually our main supply here, is 245 volts. Well, let's try that again. And let's have a look at what we are using. Okay, so it's actually going over the quoted amount there. I didn't realize that. So it's actually 1,173 watts. Okay, I wouldn't expect it to do that much. Fair enough, it just neatly trips. So I'm gonna have to find a better way of doing this. Following that slight mess up there, I've actually intentionally gone out and bought this just to do this test. This is a Russell Hobbs travel kettle. It's 1,000 watts apparently, that's the reason I bought this, because a lot of these kettles out there are 1,100, so you've got to be careful with that, because if you've got an inverter like this one, which can only do 1,000, you're going to be stuck if you've bought a kettle that's 1,100. So I've connected it up, and you can see there that it's coming in at 229.7 volts and is 53, 56 hertz. A bit all over the place, I'm not sure, maybe that's quite normal. And I'm interested to see, firstly, whether or not it can retain its voltage when it's turned on. So if I just look on the display on here, we're not at full charge here, so hopefully it should be fine. I've just got enough water in here to fill a mug like this. So let's power it up, see what happens. There we go. Okay, so it's not doing 1,000 watts, but I guess that might just be the element in the kettle. I'm assuming that it doesn't necessarily always take that much. On here, we've got it showing a little bit less than that actually. And voltage wise, we are now down at 226.7. So it's keeping it above 220, so that's absolutely fine. And we are now, as you can hear, starting to boil the kettle. I will put Amazon links to this in the description, because I find it quite good actually. It comes with the two little plastic cups like this and little spoons. I'm not here to review a kettle, but I find this quite nice. It has a slight plastic smell when you first get it, but once you've boiled it a few times, the smell goes away, and also even with that smell, it doesn't affect the taste of the tea or coffee at all, in my experience. So there we go, it's turned off now, and as it turns off, the voltage is bumped back up, so it is that drain that's dropping the voltage there slightly. And it used 43 watt hours of energy to boil that, which means that given a device like this, well, what you're probably talking about, you could boil the kettle 14 times. Allowing a bit for inefficiencies and stuff, you could probably do 14 boils of the kettle. That's assuming no solar charge on this device at all. Not bad. So build quality of this is very, very nice. It comes well packaged in a really suitable box for the size of this. It comes together with a power brick, and I'll show you that power brick here. This is a pretty hefty thing. It needs to be, because it's a 200 watt power brick, and it has your standard 50, I think it's a 55-25 connector there, output that goes into here like that for charging. And yes, this is quite big, but in my case, I don't actually mind, because of the fact that this can be used for all sorts of other things as well. So I have quite a few batteries that take this input, and this covers them all because it has a fairly substantial output. I can use this for loads of other stuff too, so it means I can just, yes, it's big, but I can just have the one plugged in somewhere and then just use it across multiple batteries. It does have a fan which is permanently on when you're using it, and even when you've got the light on here, which is red when it's charging and then changes to green when it's done, and even once that's changed to green, the fan stays on, and it's not loud, but it is quite annoying. It connects with a C7 mains connector, which of course comes with it. You get the plug here with the C7 cable. That's still wrapped. I just used one that I had available. And it also comes with a DC car socket there for charging as well, so you can just plug that into the front and charge while you're driving. And it's fairly standard stuff, this. What else have we got here? I've got a load of wires wrapped together. I'm gonna knock something off the desk in a second. And then it also comes with your MC4 for all levels of solar panels, really. This is a sort of industry standard as far as solar goes. Waterproof connectors, high current, you know, these are the real deal when it comes to solar. So yeah, we're going from MC4 to the DC 5525 again to go into here for solar charging. So they're the cables it comes with. That's everything that it comes with. It's a really nice... Oh yeah, one feature I forgot to mention, which is easily missed, because it's on the top here. You can probably... I don't know whether you can see that or not, but just let me adjust it. There we go. One feature I forgot to mention there is the wireless charging here. That is actually a really handy feature that not that many power stations have. Carrying the unit, well, funnily enough, this feels like QVC now when I'm speaking about such specific things. Look, there's a corner. There's a corner on the unit here. There's a corner on the unit. Never mind. Carrying's done with a handle. But it makes a difference with this sort of thing, because this is 9.7 kilos, about 9 kilos. It's about 9 kilos. It's about 21 pounds for our American, I think, friends. And it's a really sturdy handle. This I do like it. It's backed. The back of the handle here is rubber. The front is plastic, and it almost like, I don't know if it's magnetic or what, but it automatically kind of keeps itself down, and it totally feels like it's going to support the weight of the unit. It doesn't sound that sturdy probably won't sound that sturdy on the camera, but seriously, this handle has a really, really good feel to it. Ventilation is through an intake here and an outlet on the other side here, and it can get fairly loud. I've got a rather rudimentary sound level meter here, but I thought I'd try and do things properly. I'm just going to measure this at a distance of 1 meter. Background level is 30.7, about 30 dB. We're doing A weighting on this, which I think is generally used for kind of general background noise and things like that. So I'm going to fire up the inverter, and I've got to obviously measure it before the kettle starts boiling, because I don't want the noise of the water boiling. So let's turn that on. .44. Let's turn the kettle off again. There we go. So you can see I am in a really, really quiet environment. That drops from 44 dB at 1 meter with the unit and its fan on, and down to 30 dB. So it really is, it's not loud at all, considering this is running at its full rated capacity of 1 kilowatt. It's really not a loud unit. And the fan equally doesn't have any kind of nasty whine to it. It's a fairly sturdy sounding fan, which is unlike the All Powers device, which has a kind of high-pitched whine to it. This, I think, yeah, it makes some noise, but it's not really going to disturb you too much.
Armed.
Let's have a look and see whether we can get 10 amps out of this. Now, the way I'm going to do this is a little bit convoluted, but I'm going to try. So I'm using one of these. These are quite nice. These little power delivery to 12 volts out on here. So I'm using that together with a little power pack, little power station here. And the reason I need that is because I need to power up this device, which will apply a load to, there we go. Right, so I'm going to have to put this in some way so that you can see it. Let me just adjust my camera. Where's it going to work best? There you go. Right. And again, I was looking around and saying, God, if we've got 10 amps coming out of here, surely these are going to get pretty warm. 120 watts out of one of these little sockets. That's going to get quite warm over time. I've done that with cigarette lighters in the past, and they get really quite hot. So I think, yeah, you want to be careful, I think, when using that at any kind of high load, but it's good that it can do it, even if only for a short time. So what I did, I dug around and saw what I could find, and this is the best cable that I could come up with. This is 16 AWG cable. So I've got a male here, and I've just got to change the gender of it here, so I can plug that in. I'm not too sure about the current rating of this thing. I'm happy about this, but I'm not sure about this. Yeah, 16 AWG, this, which you'll happily, you know, I think that'll be absolutely fine for 120 watts. And then I should, on this connector here, this has got a couple of different solar options on the end of here. This, what is this, an Anderson or something? This one? I'm not familiar with this. I've never really used this before. I should be able to just clip this on here. Let's just turn this off while we do it. Right. Okay, let's see. Okay, so we can see here from the outset that we've got 13.2 volts on the DC output with no load whatsoever. So I'm going to just turn this here slowly. I'm going to start with this one. Just make sure this coarse one's down. I could start with this one and see what happens. Okay, so we start to bring in a load there. There we go. So we've got 1 amp. Let's just try and get it set to 1 amp. So we've got 1 amp here. Voltage just dropped slightly to 13.1 volts, and you can see you've got 1 amp, so we've got 10, 11 watts. That's about right? It makes sense. So let's bump it up a little bit more with the course. Okay, so we're now on, let's have a look. All right, so we're now at 4.5 amps, and we've dropped to 12.5 volts. If you want to bring up this display, you can just press any of these buttons. The first time you press them, if the display isn't on, it'll just bring the display on. It won't actually turn this off. Bring the display on. Second press will actually do what you expect it to do, like turn it off or whatever. So yeah, again, sort of 55 watts out at 4.5 amps at 12.5 volts. Sort of figures, doesn't it? So again, let's see if we can bring this right up. Hope nothing starts burning here. Right, okay, so we've now hit 8 amps and we're down at 11.8 volts. And I'm just going to check nothing here is getting too warm. And we've now, dropped to 11.7 volts. We've got 102 watts out and the fans of the unit have kicked in. But so let's see if we can take this right up to 10. Whoa, that's not good. That's not good. Okay. I'm not sure what's happened there. I think... Okay, that's good. Good to know. I'm not sure what's failed there. I think we had something jump. Yeah, it's definitely this that's failed. It's the one part that I thought would fail. So this is clearly not rated for that kind of current. Everything else was doing just fine. But unfortunately, that's not going to work. I hope I haven't damaged that. If you watch the frequency of the supply, now this could just be my meter not doing a good job of reading it, but look, it's all over the place. So it's reading kind of anything from 50 up to 61 hertz on this inverter. Now, I really don't know what the impact of this is. Someone with more knowledge on that, please do comment and sort of say, is this a problem? Because I'm going to test this in the EcoFlow that I've got here and see whether we get the same issue. Here we go, I'm powering exactly the same thing. By the way, the Bluetti does do that when the batteries are at a higher level as well. I'm not just sort of showing you a failure at a low battery level. But here's the EcoFlow, and we have a continuous 50 hertz. It did drift to 51 for a second there, but that's a huge difference. I mean, that is just pretty much rock stable at 50 hertz. So how long does it take to charge this unit, and how much power does it actually take to charge it? Because of course these things aren't 100% efficient. If you're going to charge from mains, you'll have inefficiencies going in and you'll have inefficiencies when you take power out. So it'll take more than the capacity of the battery to charge it, and again you won't get the full capacity out. So this is completely dead. If I turn the AC inverter on, it'll just turn itself off after a few seconds. So I've plugged in the actual power brick that comes with it. I'm going to do this off main so we get a constant supply, and it can permanently charge it until it's totally full. And I'm going to measure it using just one of these standard energy meters here. Great, this has now finished. And the astute among you will notice that it is now 4:58. I have been out actually, so this may have finished about 15 minutes, half an hour ago. But it's still taken about 6 hours. I started the video there at 11 o'clock in the morning. It's now 5 in the afternoon. And it has taken a total of 945 watt hours to charge this thing. Let's take a little bit off that, because if I have left this for a little bit of time, even when this power pack's on green and done, it has a drain of about 5.6 watts there. So let's be generous and take 5 off that. But basically it's taken 940 watt hours to charge a 700 watt hour battery. All right, I'm going to give you my review of the unit now. I've tried to keep fairly neutral in the other things I've spoken about. I'm going to talk about the things that I like and that I don't like. Build quality is great. Handle on the top, you can't really see that in the shot, but the handle is really sturdy. The wireless charging on top works a treat and is a welcome addition to this product. The input here is maybe a little bit limited at 12 to 28 volts, but it's suitable for the amount, for the kind of power that this unit has. So it's, 200 watts input is okay. And 12 to 28 volts will cover all sort of standard portable solar panels. Most portable ones that I've dealt with are 18 to 21 volts, so that you'd only be able to have one panel then in series. However, you could get something like a Renogy panel or something, and they're often like 12 volts for a 100 watt or 150 watt panel, and you could put two of those in series. 200 watt panels in series, you'd have 24 volts, which would well be in the capacity of this. I'd probably prefer an XT60 on here. I'm not a huge fan of these sort of connectors. I think they're a little bit more prone to breaking. I've seen a lot of these kind of connectors break on the back of laptops in the past. But yeah, I'd prefer an XT. I'd prefer something like, where's the cable that comes with it? It's not this one, is it? But something like this kind of thing, I prefer that sort of solar connector. It's more standard and a little bit more robust, I think. The display is good, and I'll just show you that now. We've got input and output power here shown clearly. People complain about this because you only have your 5 segments of battery, so you can only see, is it 20, 40, 60, 80 or 100? And a lot of people say, oh, well, I want a specific battery. I want to know how much time is left on the unit. And while I do see that that's nice to have, and it's definitely something that I enjoy having on other units, after a while, you really tend to ignore it for 2 main reasons. Firstly, the amount of power that gets drawn from this type of product varies all the time. So it's not often that even if you're using it for you're working at home or something and you're using a laptop, the power that laptop draws on something like this will change continuously depending on what you're doing on the laptop. So really, time remaining is a meaningless figure. And equally, the second reason is that a lot of power stations like this, including this one, are not that great at calibration. As in, there are certain ones that will get to 0 or 1% and then last for another 5 hours at high power on 1%. That's what happens with my EcoFlow products. On the flip side of that, my All Powers products drop to 30% and power down. So the calibration side of them is always a bit sketchy. And sometimes there are methods to recalibrate them, but a lot of the time there aren't. And so I just find that although it's nice to have that figure there and have that percentage figure there, unless it's really, really accurate continuously, it's sort of pointless. So I haven't really missed it at all. This has been quite sufficient. And yeah, it's perfectly suitable for what you're going to be using this battery for. The light here, I've never quite understood this. Yeah, fair enough. You can have a you can have the SOS, and it's a useful feature to have if you need it. But as for a light, this is pretty horrible. I mean, it's bright. It's just bright. It just looks like a cheap torch, and I just think this could have been made so much nicer. If you look how Anker do them, they put like a nice kind of strip light across, warm LEDs, and it's really, really useful. It just has a background light in a room or in a tent. This is just, I mean, would you honestly want this on? What are you going to use it for? I don't know. Someone put in the comments and correct me. Maybe there are really good uses for lamps like this, but I think this is a poor implementation of a light, in my opinion. AC inverter side is fine. The capacity and the capability of the AC inverter is no problem. I found the inrush current on my fridge at home. I tried to run my fridge with this. I found the inrush current on the compressor on the fridge was too much for the surge on this, and it just cut out. When it does cut out, it cuts out very gracefully, very nicely. You can just turn it back on. But it means that I couldn't run my fridge off this, whereas I can run my fridge off my Delta Mini, my EcoFlow Delta Mini. So I was quite surprised that even at 1,400 watt surge, it wasn't sufficient. But overall, it runs electronic devices fine. It has a good sine wave, and the inverter is not really a problem. And the DC out, I'm totally happy with that. It's got good capacity on the 5521s, and it has 5521s, great for me. A good range, just a two power delivery, 100 watt, 2 USB-A, perfect. Cigarette socket. Overall, other than that, I really can't complain. It can get a little loud, I suppose, but these all do. You're shifting a lot of power in these things, and they've got batteries in. You've got to be safe in that regard. So yeah, they're going to get a little bit noisy at times. Would I recommend the EB70? Absolutely, yeah. I've been really impressed with it. It's done everything I wanted it to, and everything I expected it to. It's a solid unit, really nicely made. It feels sturdy, and it delivers all the power that you need. It's got a nice capacity, so it's not too big to be super duper heavy and unwieldy, but it's also not too small, so then you're not end up sort of thinking, oh, we're not going to be able to have enough power for the day. You can happily take this away maybe for 2 nights, and you've got enough power here to boil a kettle like sort of however many times, like maybe 7 or 8 times, and then probably if you don't use that so much, you've definitely got enough power then to charge your phones, and power your laptops. And really, it's a good amount. And if you can get solar into it as well during the day, then that's even better. But it's a good product, and I would definitely recommend you taking a look if you're after something like this. I'll put a link in the description, but if you've got any questions, put them down in the comments, and I will answer within 24 hours if I can. And other than that, thank you very much for watching. See you again soon.